Hello guys, welcome back to the Unit 3 review lessons, where we are covering some past paper questions that cover topics from Unit 3 in particular. In the previous lesson, we looked at the CPU and primary and secondary storage, and in this lesson, it's simply input, output, and sensors, where we have to demonstrate our knowledge of these types of devices from Unit 3 in our syllabus. You can find the question papers and the mark schemes available in the description below, and as mentioned in my previous lesson, there are 3 parts to the review of Unit 3 as it is quite a large unit, and this is the second of those 3. So let's jump straight in and let's look at question 1a, which is talking about audio and how audio is represented in a computer. We have a musician who is recording herself playing music using a piano, and we need to explain how the analog sound is recorded and converted into digital, which is what a large part of this unit is all about. So first and foremost, the analog sound is recorded using a microphone. I'm just going to write mic for short. And to do this, the sound wave in particular is what we call sampled. So we take a sample of the sound wave, which measures the height or amplitude of the sound. So this already, guys, will be 3 marks in the exam for these 3 points. And then we need to say that each amplitude or each sample has a binary value, where we then need to mention 2 keywords from the audio lesson, which is sample rate and sample resolution. And of course, we have to define what these terms mean, where the sample rate is the number of samples per second, and the sample resolution is the number of bits available for each sample. So quite a tricky topic. Please go back and watch the video if you are struggling with audio representation. But these are the keywords that the examiner will be looking for when it comes to analog to digital sound. Question 2, nice and simple. A student has several hardware devices to complete his homework. The computer has a CPU. The student uses a keyboard to complete the schoolwork. Tick which type of device the keyboard is. So this is fairly simple, guys. The topic clearly states input, output, and sensors. So you should know that a keyboard is an input device and that a printer used to print things is an output device. So really easy, and that should be a guaranteed 2 marks in the exam. Question 3, we have a train station, and the ticket inspector at the train station checks each customer's tickets before they are allowed on the train. The train station wants a system that will allow the tickets to be automatically checked, and we need to identify 2 input devices in order to read the tickets. So you should think back to the sensors and what kind of sensor could read a ticket. Well, if you think of any train station or even an airport, you know that we have a barcode scanner, or more recently, we now have QR codes, which are read by a camera. So these are the 2 input devices that could read the information from a ticket. The train driver pushes a button to close the train door when all passengers have boarded. The train door will only close when there are no passengers in the doorway. The system will check that there are no passengers using a sensor and a microprocessor. Explain how they work together in order to check whether the train door can be closed. So this is a very common question, guys, where you have to talk about how a processor and a sensor work together. And you can typically find a good 6-mark question on this topic, where once you understand the pattern, again, it should be an easy 6 marks to pick up. So first and foremost, in this question, we have to highlight which sensor is being used. And in a doorway, we could use a proximity sensor, an infrared sensor, or even a pressure sensor in order to check for somebody in the doorway. So that is 1 mark for mentioning the type of sensor and then saying used to check if the doorway is clear, and that will be 2 marks. You also need to state, and this again goes for most of these questions, the sensor continuously, so this is the key word, continuously sends data to the microprocessor. So again, no matter what scenario this is in, the sensor and the microprocessor will always have this going on. No matter what the scenario is, always get this point in there. And again, the next point, do the same thing. The microprocessor compares these values, so compares the data that it's received from the sensor, and it does this by checking some stored values. So the microprocessor is programmed to operate in a certain way. It will check if it's in a certain range, for example, which in this case, if sensor detects a person, the microprocessor sends a signal to close the door. And again, it's just about applying this knowledge to a scenario, as the scenarios will differ from exam to exam. So far we've covered 1, 2, 3, 4, 5, 6 marks. What you'd also say is that if nobody is detected, the door, oh, I've done this the wrong way around. Sorry, guys. If a sensor, let's go back to this point. If the sensor detects the person, the microprocessor sends a signal to keep the door open. That's my fault. To keep the door open. I've done it the wrong way around. Keep door open. If nobody's detected, that's when the door will be closed. So hopefully you picked up on that. If nobody's detected, the door can close. my fault. And then finally, for the last mark, really easy. The whole process is repeated until the door is closed. And what you might find in mark schemes is that sometimes this is worded as process is continuous. This is a common mark scheme style answer. So the whole process is continuous, meaning it loops round. It keeps doing it until a certain condition is met. But as you can see, guys, 6 marks available. You've got more than 6 available from those points. And it's just about applying this knowledge to different scenarios. Question 4, a mobile telephone has a built-in input and output device. Give 2 examples of an input device that would be built into a telephone. So the first input device that comes to mind with me with the phone is the microphone. Obviously, we speak on a phone, we send voice notes. So the microphone takes in our voice. And also we have the camera, which also takes in a picture. And the camera you should know as an input device. And just for good measure, we can also mention a touchscreen. So a touchscreen. However, if you say touchscreen here, you can't say it in the output device, because although a touchscreen is both, you can only mention it in one. You could also mention a keyboard or keypad. If it's an older style phone, some phones do have buttons for the keyboard rather than the virtual keyboard on the screen. So you can mention that as well. But if you don't mention touchscreen in the input, you can put it in the output. And then you can also put a speaker, because this output sound. And you could also mention the light as well, this output light. So nice and simple input and output devices. And then let's move on to question 5, which is talking about an inkjet printer. So the paragraph describes the process of a document being printed with an inkjet printer. Remember, you need to be able to describe an inkjet printer and a laser printer. So complete the paragraph using the most appropriate terms from this list. Not all of the terms will be used. So first and foremost, data is sent from the computer to the printer. The data is held in a print buffer, so a place where the documents are stored whilst they're in a queue. That is a temporary storage until the data is processed to be printed. Inkjet printers operate by having a printhead that moves something from side to side. So which one of these things moves from side to side? That is the nozzle or nozzles. And these spray liquid ink droplets, so liquid ink, onto the page. These ink droplets can be created using piezoelectric or thermal bubble technology. So some very particular keywords that are specific to an inkjet printer. But what you should be doing is noticing that lasers and drums, powder, toner, these all refer to a laser printer. So you should be ticking them off anyway. And then moving on, if the paper jams in the printing process, the printing stops and an interrupt, which is part of another unit, is sent to the computer. So again, guys, very particular for an inkjet printer. Just be aware that you have to be able to compare inkjet to a laser, to just be on top of that. So continuing on from output devices, a printer is one example of an output device. Give 3 others. Nice and easy. First one, monitor. You've got speakers and headphones. Please be careful, guys, as to what they're outputting. Speakers and headphones do output sound, so try and think of some more. We've also got projector. And then from the sensors lesson, we have actuators, so some kind of movement. Input devices, we have many more. Keyboard and mouse being the obvious ones. We've also got a scanner, which is the opposite to a printer. We've got a camera or a webcam. You could also mention a touchscreen or a sensor. And if you wanted to name a sensor in particular, that would be fine, but you can just say the word sensor to cover all aspects, or even a barcode reader, as we mentioned before. There are a bunch of input devices to pick from. And again, please make sure you're on top of the differences between input and output devices. Question 7 is talking about a QR code reader, a quick response. So a QR code allows visitors to view videos for extra information about items in a museum. The visitor is given a portable device with a screen that they can use to read each QR code. Describe how the QR code is read and processed to display the video for the visitor. So first and foremost, with a QR code, the corners of the QR code determine the position or the orientation, so which way up it should be, whether it's top left, top right, bottom left, or bottom right. The black and white squares reflect light differently. That'll be 2 marks. The camera or the device, in this case, the device, or if it's a phone, you could say camera, captures this light, which is another mark. Simply saying the word sensors, so using sensors is another mark. And then the reflections are converted into binary, which will be the link for the video. So the binary converts into a link /website for the video. And this is the same for most QR codes, whether it's on a ticket for a concert or in the train ticket, as mentioned before. This is how they all work. And as you can see, we've got 1, 2, 3, 4, 5, 6 possible marks for the total of the 4. And that is how a QR code is read and processed. Question 8, a robot has a sensor and a microprocessor. So this is similar to the question from before. The robot will move forward continuously until it detects an object that is less than or equal to 10 centimeters in front of it. If an object is less than or equal to 10 centimeters, it will turn 90 degrees to the right and then try to move forward again. explain how the sensor and microprocessor are used to automate this robot. So just like last time, guys, the first thing you should be thinking is what kind of sensor can be used to detect in this scenario. So in this scenario, the robot is moving forward. What kind of sensor will detect something in front of it? Well, the same as before, proximity or an IR, so an infrared sensor. Second mark will be used to detect objects in front. Again, the sensor continuously sends data to the microprocessor, which is just the same as before. And now, because we've been given specific data to work with, the microprocessor compares the signal or compares the data to 10 centimeters. If data is more than 10 centimeters, signal sent to keep robot moving or to move forward again. Keep robot moving. And then if the data is less than 10 centimeters, signal sent to make it stop and turn right. And then just to make sure we get all the marks available, we can mention the device which turns the robot to the right, which is an actuator. So this is done by an actuator. And again, that same mark for this type of question, the whole process is continuous, or the process will repeat. The whole process is continuous. It's essentially a loop that will just keep going until the robot can't actually move. And then to finish off, guys, we've got the term LED, which is a light emitting diode, and we are referring to a screen, so an LED display screen, where we need to describe how the LED operates to show a video. So if we remember, all displays use pixels, so display is made up of pixels, and the LEDs, so the really small light bulbs, so the LEDs are behind the screen, and each LED displays the color of the pixel using, so this is an extra mark, an RGB filter, so red, green, blue, RGB filter that will determine the color of each pixel, and this is used to create different colors. So this is an extra mark, which is quite a difficult question to get the marks specifically, but that is what we're looking for an LED screen. Remember, you have to talk about an LCD screen as well, which is a liquid crystal display, which uses a panel of liquid and will shine light onto this liquid in order to display the image using the same thing as pixels. But remember, LED and LCD, we do have to compare the difference. And that's it for this video, guys. This is the second video of the 3 for the Unit 3 review videos. There's one more left, which is network hardware. Documents available in the description, as well as the mark scheme. And please stay tuned for the following video, which will be posted shortly.